All right. Hello, everyone. Welcome to the second day of the CONFERS Global Satellite Servicing Forum. I'm Brian Whedon, Executive Director of CONFERS, and we're excited to have everyone here for the conclusion of this year's event. Yesterday, over the first several hours of content, we saw discussions about sort of the advances that we've been making in commercial satellite servicing, some really exciting new demonstrations and actual missions, and discussions about business elements and where some of the technologies are headed. As we go into our second day of discussions, I want to open up just by once again thanking our sponsors who helped make this event possible. We've got Astroscale, Space Logistics, Space Able, Voyager Space Holdings, Space Infrastructure Foundation, Orbit Fab, Lockheed Martin, MDA, Aerospace, and Space News. Thank you all for your support of both CONFERS and of the Global Satellite Servicing Forum. Before we get to our program this morning, I do have a couple of housekeeping items to cover. Reminder that this meeting is on the record and is being recorded. The recording will be available to registered participants shortly after we conclude, and then we will be making it publicly available at some point in the future. We also like to continue to make this event as interactive as possible. So please, so those questions that have, those sessions that have a question and answer element, please submit your questions using the Q&A function on your toolbar at the bottom of the Zoom window. We ask that you save the chat for any general discussion, but specifically for helping resolve any technical issues. We will not be monitoring the chat for Q&A. Also note that we do have a few elements of the program that are pre-recorded. We've done our best to try and match audio levels of all the content, but also keep in mind you can adjust your own audio volume levels should you need to. I think with this, on this slide, for those who aren't familiar with this interface before, if you get down to the bottom, you click the little Q&A button, you can pop it up and you can not only see the questions, you can add your own, and then you can also vote on questions raised by other people. So with that, I would like to reintroduce Mr. Joe Anderson from Space Logistics for a few opening remarks as our titanium sponsor for day two. Joe, the floor is yours.
Great, thank you, Brian. And if you could bring up this slide, thank you. So good morning, everyone, and welcome to day two of the Global Satellite Servicing Forum. Yesterday, in the introductory panel that discussed key operational events of 2021, I highlighted what I think is the industry's Kitty Hawk moment with the success of Space Logistics MEV-1 and 2 operational servicing missions. Not demos, these are revenue-generating servicing missions. At the end of that briefing, I hinted to our second-generation servicing system that is shown in this figure, with our mission robotic vehicle installing a mission extension pod onto a client satellite. I'm happy to report that 2021 has also been a banner year for the development of this system. In the past 30 days, we completed the mission and vehicle PDRs. We signed a contract to launch the mission robotic vehicle and the first 3 mission extension pods in mid-2024. And as an indication of the market demand over the past couple of years, we have signed term sheets for 7 mission extension pods with 6 different operators. As a result, our mission robotic vehicle manifest is now booked for 2025 and much of 2026. These facts should make it pretty evident that persistent robotic servicing in GEO is an imminent reality. With these facts, and in the spirit of Pam Elroy's keynote yesterday when she said, "We need to collaborate to compete," I wish to place a challenge to our industry. How should we design our next generation of spacecraft, knowing that there will be persistent robotic servicing available? What should satellite manufacturers do differently? What should our satellite operators be asking for in their next procurements? Should we design for serviceability? What are the key serviceability features to include? Is it refueling? Is it a power and data port? Is it something else? Do serviceability features require technical standards? These are the type of challenges that the CONFERS Technical Working Group are trying to collaboratively tackle, working through all of our international members. If you would like your voice heard in these discussions, I highly encourage you to join CONFERS and join our discussions to pioneer the future of space. Thank you for being with us today. It looks like we have another outstanding agenda. I know that I am looking forward to another day of learning, collaborating, and growing this market together. And here next is John Goff, the Vice President of On-Orbit Servicing for Voyager Space Holdings, to introduce our keynote speaker.
Thank you, Joe. So as you were saying, I'm Jonathan Goff, Vice President of On-Orbit Servicing at Voyager Space Holdings. We're a vertically integrated company that runs a number of tech subsidiaries in the space supply chain from low Earth orbit to the lunar surface and beyond. One of our focus areas is developing the interfaces, robotics, and space systems needed to enable affordable satellite servicing and orbital logistics. Today, I'm introducing Dr. Rolf Densing, the Director of Operations and Head of ESOC, the European Space Operations Center, which is Europe's Center of Excellence for Satellite Operations, as well as being a Center of Excellence for space debris studies, orbital debris mitigation measures, and space situational awareness. Prior to starting as the Director of Operations and Head of ESOC in 2016, Dr. Densing spent 23 years in various technical and leadership roles in the German Space Agency, including serving as a project manager for several space science missions, serving as the US representative in DLR's Washington, D.C. office, serving as the head of the executive office at DLR's headquarters in Cologne, and finally serving as the Director of Space Programs, where Dr. Densing was responsible for Germany's involvement in ESA's research, technology, and infrastructure programs. And with that background, I'd like to hand things over to our keynote speaker, Dr. Rolf Densing of the European Space Operations Center. Thank you, Dr. Densing.
Thank you for this nice introduction, and good morning to everybody. Actually, it's afternoon here, but I saw you are around 9 o'clock. It's a pleasure and an honor to be with you today, and thank you very much for this kind invitation. After the talks I've heard already since this session started, I must say I feel at home. If you could go to the next slide, I believe I have no control over this. So ESA started a comprehensive space safety program about 2 years ago, and this encompasses all kinds of hazards that are originating in space, such as near-Earth objects that could plunge into Earth, such as space weather originating mostly from solar events, and such as space debris. And during the 2 years that we are running this program, the number of objects in orbits around us has already increased by 1,500. So our people, we are running a space debris office since decades, I must say, even though we have no own intelligence on space debris, but we are doing it, we keep all kinds of statistics and we do all kinds of research and modeling. So, if we add it all up for this happening around us, if you click twice more, sorry, I should not have put this animated. Yeah, you see where the steep increases come from in the amount of objects around Earth. This is pretty much self-explanatory, I believe, what you see. It's a number of objects versus time and origin. And so we had two events where there were steep increases. And if you click once more, if we add it all up, click, 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 once more, and yes. And if we add it all up, I guess we know, actually not we, our US friends know 28,000 objects that they are tracking that are the size of 10 centimeter or so, at least as far as we can guess. They add up to 8,500 tons and have a size of 88,000 square meter. That may not mean much to our American friends. This is about the size of 12 football fields. So bad enough. So we are very conscious that space is infinite. And so I have children and I'm determined to leave some space behind for our next generation. Let's go on to the next slide. Click once again. Sorry, next time I do this, I put out the animations. So here we are looking at one of our Sentinel satellites. Sentinel, or better known as Copernicus, is the program, and the Sentinels are the individual missions. We in the European Space Operations Center are flying 5 out of 8 of this constellation, and there are plenty of more to come. And here we have before and after pictures. This is one of the few satellites that we are operating that has a selfie camera on board. And one day, our operators realized a loss of power and a torque on the spacecraft. And sure enough, and looking at it, the solar panel got hit by a piece of space debris. Our people analyzed things back and came to the conclusion that the space debris that was impacting had a size of about 6 millimeter. However, it crafted a crater of about 4 centimeter, and yet again, it set free 8 more pieces of space debris. So this is how this avalanche effect goes. By the way, the satellite is flying perfectly fine. It's doing everything it should do. It's generating 10% less power, and we are perfectly at peace with this. If you go to the next slide. This shows you very pictorial what we are up to. We are getting in our European Space Operations Center. Maybe I should explain a bit what we are doing here. We are not organized like many other space agencies. We have centralized to the European Space Operations Center the operations tasks. So we are flying all kinds of missions, maybe Earth observations, maybe space science or whatever. And we are doing this for the European Space Agency. Actually, we are part of the European Space Agency, but we are also doing it for third parties. For example, the Copernicus missions that are part of a joint ESA-EU constellation. And we get in about a couple hundred collision warnings every day, mostly from our US friends, because, as I say, we have not much of an own catalog. I believe our friends are very much interested to make sure that we don't collide somewhere. And so we get a collision warning. And here we got one that was about 4 weeks ago, I believe, between another part of our Sentinel constellation, Sentinel-1B, and the fragment of a Chinese rocket stage. And the probability was 1 to 50. So if I had a chance of winning a lottery in 1 to 50, I would certainly play lottery. Now, the conclusion I would like to draw is, as it gets more crowded in space and collision warnings get more frequent, we need to find smarter ways of coping with this. We cannot keep doing this manually. This requires communication. I mean, not with a fragment, but if 2 active satellites, steerable satellites, are concerned, it starts with negotiating, and so there's a lot of stuff that you can automate. If you go to the next slide, but let's look at the origin of space debris first. So there's again a timeline and the percentage of conjunctions warning that we are getting. So in the old days, it was very much payload related, dominated by payloads. Then, of course, in the old days, we had rocket stages that were frequently left behind in orbit, and I believe Ariane 5 still does it. Ariane 6 will not, has a much better sustainability rating, and nowadays satellites in orbits around us are taking over. If we go one further, go on, just go on to the next slide. Click. Thank you. And this shows the evolution of number of objects in space, actually bigger objects, satellites, and well, I guess you can read this. This is timeline again, and I guess the yellowish bar on the right shows the dominance that we have, which is due to the arrival of mega constellations. So I think it's perfectly fine to have such great ideas and to have to operate mega constellation. Space is there for everybody, but it's also a bit of a concern that it's raising, and this challenges us to come up with more clever ways of doing collision avoidance and of observing our orbital environment. Actually, what we have done is we have started a machine learning challenge by uploading our historic collision avoidance data to the internet, and have invited the expert community to come up with algorithms on how to best do collision avoidance and analyze the situation. And we have received great input, and we are working with some of these experts, and we are very much involved in this and very much determined that we would like to stay out of harm's way, and that we would like to do so as automated as possible. Let's go to the next slide. Of course, the best way to deal with space debris is to avoid space debris. I mean, not to cause space debris. I will come to this for the time being. I guess we have the code of conduct on the mitigation of space debris, and this ADAC rule. I guess the community, all of you knows what I'm talking about. It is saying that 25 years after end of operation, orbits should be cleared, and may it be, if you look to the right side, by pushing an inactive satellite to graveyard orbit, or if you look to the left side, may it be by making an object re-enter into atmosphere and disintegrate. So also passivation is important. So the switch off procedure, freeing up the frequency spectrum, purging tanks, and all of this kind of stuff to avoid explosions, which will add to space debris. So far, the code of conduct, but if we go on to the next, this for one reason, if you go to the next slide, this for one reason or another does not always happen. So this is again a timeline, and in the vertical axis you see the adherence to this code of conduct. I must say this entered into force in the early 2000s, and the green ones are the successful attempts of freeing up orbits after 25 years. I must say this is since this code of conduct is not in effect for so long, no wonder that in the early years we do not see much of an effect. But at some point we would hope that we would successfully clear orbits with a 90% success rate, and we have ways to go to do this. And this is why we are proposing, if you go to the next slide, and actually developing in ESA technologies to avoid space debris. Actually, we would like to introduce this into our own program, and with the idea of being space debris neutral by the early 2030s. So the idea is for the smaller and LEO satellites to have a track augmentation device that we would deploy after end of operation, and with the idea that the track would make the satellite inoperable, or satellite that has finished its operation, make it enter into Earth's atmosphere sooner than the 25 years. And for bigger objects, we would have a redundant and fail-safe deorbit engine that we are developing, so that we could have a targeted deorbiting or push in a graveyard orbit. Our Director General made an announcement accordingly last week, which was reflected in the press also. We would like to go even further in ESA. If you go to the next slide and look at circular economy in space and to make our activities in space more sustainable. This is by adopting a new culture, probably not new for you. If you go to the next slide, we would like to go from a throwaway culture into a reuse culture. So it's pretty benign, and I guess you all are very conscious of this. And if you go to the next slide, and this is then looking into in-orbit servicing. Actually, part of our space safety program that I tried to explain at the beginning of my talk is what we call the ATRIOS program. And ATRIOS stands for Active Debris Removal and In-Orbit Servicing. And we are preparing, in terms of in-orbit servicing, a proposal to our ministerial conference. Those are conferences that happen about every 3 years. And this is where the space ministers of our 22 member states come together and subscribe to our program proposals. So they put all their money in one pot and ask us to implement certain proposals. And we will certainly make a proposal on in-orbit servicing. And if you go on to the next slide, so we have developed over the years plenty of technologies. Like on the right, I see close proximity operations is what you need. By the way, on the very left, the reddish one, we will get to this. This is an artist's conception on how we want to, for the first time, remove a piece of space debris. And actually, on the next slide, we see it. And as I said, ATRIOS stands for Active Debris Removal. This is ongoing. Mission is due to launch in 2024. And then we are in the concept phase of in-orbit servicing. So the plan for active debris removal, and this is, by the way, the first time this has ever been attempted. Now, I know there will be people, in particular, that we have an expert community that will say, I have done it, it's been done before, but let me explain. We are actually planning to launch a chaser spacecraft. This is kind of like an octopus. It has tentacles, and with the tentacles, it's supposed to fly to a 600 by 800 elliptic orbit, capture VESPA payload adapter of one of our Vega rockets, and bring it back to atmospheric track, where it then will on its own re-enter into Earth's atmosphere. And we are leaving nothing behind in space. Upper stage of the launcher will get returned by return engine, and certainly the chaser and certainly the target object will get returned. And it is new, I believe, at least I'm not aware of this ever having been done. It is new in respect that after completion of the mission, if all goes well, there will be one piece of space debris left in orbit. Now, obviously, this is for the time being a demonstration. It's a one-off. It's costly. It's our cost. We are purchasing it as a service end-to-end from industry. We are offering them technologies that we have developed that is available to them. We offer them. Actually, we are talking about a small startup, but we are helping them as good as we can. This is a 100 million euro project. But the hope is that in recurrent phase, that they could come considerably down by a factor of 10, if not more, so that in case of need, they could actually make a business case out of it and deorbit objects more frequently. And then if you go to the next page, obviously, we need to extend the active debris removal and go become serious about this circular economy in space, and foster and develop a market for in-orbit servicing. Here we are not the first ones. This has been successfully demonstrated. Congratulations to folks who did it already. And as I say, if you go to the next slide, we will be issue an RFQ is what we call it, a request for proposal for in-orbit servicing, and it has to involve AOC, either AOCS, takeover, refurbishment, assembly, refueling, or manufacturing. So those are this is the purpose that has to be part of the proposal, and this is targeted to our 2022 ministerial conference. So we want to propose this to our member states. I'm confident that they will sign up for it, and then we start demonstration. And the idea is, of course, to foster a market. So we will do a pilot, and the hope is that industry will take over, that we all change attitude, that we all take steps to leave some space for our children. And with this, I would like to conclude. Thank you very much for listening, and thank you very much for your interest.
Okay, hi Rolf, this is Harley.
Hey Harley, long time no see.
How are you?
Good seeing you again.
Good to see you again as well.
I saw your name.
Seeing you brings back memories when, some decades ago when we were trying to change NASA's and ESA's future.
Yes.
Any case, terrific presentation. There are a lot of questions. So beginning, and I'm going to try to summarize a bunch of them. Some of them are very similar. You finished with a discussion of possibilities for mandatoring satellite demise. Let's see, how is that going in the US or internationally? And maybe this is a guess. What do you think the chances are of implementing it?
Well, there is building for demise, I guess, is helpful already. So we don't want pieces of space debris falling on the ground. So I'm not aware of any human casualty. I've heard that a cow in Australia once got hit by a piece of space debris. Actually, which is bad enough. Where was I? So building for demise, taking the right material, this is one thing. We in ESA are determined to not leave our satellites that went out of operation in orbit for 25 years. We want to bring these satellites, inoperable satellites, back as soon as possible after finishing operation. And if onboard resources will not permit, we would have either this track augmentation device or a return engine. Now, whether others are going to adapt this, this is up to them. I would hope that the community would follow this example. We are actually working with industry, hope for a very competitive approach for return engines. I believe there is a market also for strap-on return engines, compact, low mass, very safe, and for this track automation, augmentation devices. So we are at early stages. The idea is to be neutral in the early 2030s.
Okay, good. A couple more questions, kind of quickly. So we have about 4 minutes left. Have you looked at, or have your colleagues and so on, looked at post-mission disposal performance in GEO or other orbits, other higher orbits than LEO?
Well, this, as far as this return engines, this is the same, I would guess, the same principle. I must say, we ourselves are not operating much in GEO, as you know, Harry, we are the Earth observers and the science satellites that we are flying. But I guess the principle must be the same, what we call a return engine, one could also use as a graveyard engine.
Are there any legal implications to collisions in space? You're talking about legal requirements or contractual requirements for upcoming missions to be properly disposed of. Currently, though, are there any legal requirements?
No. What I was talking about, Harley, is a how should I say, more liberal code of conduct where people can or cannot adhere to. This is not a legal requirement. This is a code of conduct for the what do you call it? Not mitigation. I forgot what they call it, for the avoidance of space debris. So nobody can be forced to do it. Most major space agencies of the world have subscribed to it, and even SpaceX and OneWeb, I believe they are making every effort to adhere to it. But if you have a constellation of 10,000s of pieces and you adhere to the code of conduct, and if you keep building constellations up, this means, what does this mean? You can use your fingers and count what that means. And I would perfectly, so I'm not, how should I say, perfectly fine if people use space to do their business. Who am I to tell they shouldn't? Maybe we should rethink this 25-year rule.
Mm-hmm. Okay, we've got, again, a couple more minutes left. Here's an interesting question. The question runs a little bit long, so let me see if I can distill it. It looks like slow, but quite possibly real progress is being made in the spacecraft disposal and spacecraft incorporating disposal. You guys are talking about some future additional activities. Now, this person points out currently ground tracking is fairly reliable for collision avoidance. However, as the satellite operators add, as what he refers to, steering or sidestep capability, you're going to have to rely on a collective planning database or a very local steering for the potential target for this type of satellite. Can you share your thoughts on coordination among the satellite operators of all kinds? It seems like the world is becoming increasingly complex, not only in number, but in complexity of the satellites.
Well, this obviously has security implications. And we in Europe don't have much of a catalog. So as far as I know, the most comprehensive catalog is kept in the US. That's the 28,000 pieces I was mentioning. This is what we guess. Pieces the size of 10 centimeters. To knock out a satellite probably doesn't need a 10 centimeter piece. A smaller piece will do perfectly fine. And therefore, we cannot share much among operators. So we are pretty much dependent on US sources to manage our collision avoidance. We do compare notes on how we do collision avoidance maneuvers. Actually, what we do in ESOC has been blueprint for many operators around the globe. The way we are doing it, we are a vivid member of this IADC. Let me see if I can figure that out. The International I forgot the pre-coordination committee and so on. So our whatever we know is available to the world. So we do have software that we make available also for flying collision avoidance maneuvers. We share what we have. It has been developed on taxpayers' money. It's there to keep the use of space sustainable, and hence it's available for everybody to use. And we are not claiming that we are the only ones or the best ones. But I guess I hope we would all have a common goal.
Okay. All right, Rolf, we've run out of time. Thank you again. Good to see you again.
I thank you all.
Take care.
Okay, take care. Bye.
Bye-bye.